Hello and welcome everyone to MSc Software's webinar series. Today we will be discussing Patran 2017 and its new features and capabilities. My name is Farnaz Jadbabi and I will be the presenter for this webinar. Shortly after, we will have a demo session by Atul Chahal from our product team. Let's get started. The purpose of today's webinar is to introduce you with the 2017 release of Patran and show you some of the new functionalities and enhancements. We will start by integration of Patran with MSc Nastran embedded vibration fatigue. You will see how Patran can be used for pre- and post-processing of fatigue calculations in frequency domain. Next, I will show you how HDF5 result files from MSc Nastran can now be imported in Patran for post-processing of results. I also like to let you guys know that Patran 2017 will support Windows 10, which is what most of you guys have been asking for. Lastly, we will go over the new and enhanced user interface that has been added to Patran 2017 to improve user experience while providing the same set of capabilities and features in all supported platforms. Let's start by going into the vibration fatigue capabilities of MSc Nastran and Patran. Before we go into details, I'd like to give a short background on fatigue and vibration fatigue. What is fatigue? Although fatigue can have several definitions, the one that's most common among engineers is failure under a repeated or varying load which will never reach a level sufficient to cause failure in a single application. So in other words, the load, if applied once, will not cause failure in the structure. As we know, most structural systems undergo cyclic loads during their service life, and designers need to ensure that the structure does not fail early in life. That's why fatigue or durability studies are a critical part of product development. Because if we know when the structure will fail or how the structure will fail, we can save a lot of cost and time in our process. Now, why do we have to care about the dynamic features or the vibration fatigue? What is vibration fatigue? All fatigue is dynamically induced. That is, there must be some level of dynamic loading in order for fatigue damage to occur. Now, since long time, engineers know that frequency domain methods for structural analysis offer very qualitative information about the structural response. That's why it's important to understand the behavior of structure in the frequency domain. Vibration fatigue is the estimation of fatigue life when the stress histories applied to the structure are random in nature. That means they're not repeated in the same manner. In this case, these type of loads can be best described using a statistical process. Now, we all know that frequency response analysis is widely used in many different industries. As you can see here from this slide, some of the industries include aerospace or auto industry. For example, in the aerospace, we have aircraft structures design, we have satellite design, or in the auto industry, we have the full car or truck body design. All these structural problems can be solved using the frequency methods. Up until now, fatigue analysis was mainly dealing with the time variation of the load. As you can see from the slide, the time domain fatigue analysis consists of defining the load with respect to time and running it for all the inputs, running a standard static transient analysis. In MSc Nastran, this will be solution 112. Later on, the local stress time histories are recovered and they will be converted to fatigue life using the standard and accepted methodologies in the fatigue modules. Now, this approach is really good, but it may not be always the best options for many real-world applications because most complex structures are often influenced by some type of dynamic load. Using the new and innovative vibration fatigue modules inside MSc Nastran, engineers can now perform fatigue analysis in the frequency domain and benefit from this computationally efficient procedure. The procedure is shown here, as you can see from the lower image. First, the structural response or the transfer function is calculated. This is nothing but the result of a solution 111 or modal frequency response analysis inside MSc Nastran. Here, it's important to note that the transfer function itself is independent of the input loading and is a fundamental characteristic of the system. Once we have the transfer function, we're going to multiply it by the input PSD or the power spectral density function to generate the PSD response or output PSD. So what is this power spectral density function? Generally, this is the most common way of representing the loading and responses of the structure in the frequency domain. Another way to look at it is as the equivalent to the time history that's obtained using the transient approach. Once we have the output PSD, the fatigue life is directly calculated from these stress PSD responses. The calculation can be done either using the rain flow histograms or fatigue life can be calculated directly. Let's start discussing some of the benefits of the frequency domain over the time domain. We all know that Nastran is the premier choice and leader for performing dynamic analysis. With the new capabilities in Nastran and Patran for fatigue calculation in frequency domain, we can now have one random analysis run that includes the fatigue calculation. So this by itself can benefit engineers in many ways. First of all, the analysis process is much faster, because the fatigue calculation is not seen as an afterthought or a post-processing option. Rather, calculations are done in the same MSc Nastran run. Another benefit can be the reduction in scratch spaces or disk space. For example, very large models such as a full-body car or a truck model can be analyzed using this new method. Most calculations are done in core, so there is no need to keep intermediate files around. This can save us a lot as far as the scratch spaces or dramatically reduce the disk space requirements. Up to 90% reduction can be obtained using the frequency method in comparison to the traditional time-based methods. Most importantly, when it comes to fatigue life and damage calculations, the frequency-based approach offers far more qualitative information about the structural response. For example, the transfer function itself provides unique information about how and why the structure behaves in the way it does. It gives us a lot of options and information about the fundamental characteristics of the structure. Another benefit of using fatigue calculations inside MSc Nastran and Patran is the ability to optimize the results using the damage or life constraints in solution 200. Most importantly, the accuracy of results. Of course, accuracy is the highest of interest when it comes to performing finite element analysis. It can be shown on this real-life structure that the calculated fatigue life is within a factor of 2 difference between the two solutions, the time-based solution or the frequency domain solution. This is generally a good result because engineers have an agreed view that any two fatigue damage or life results that vary by less than a factor of 2 are actually considered as the same results. The stress change needed to cause a factor of 2 difference in damage results is usually less than 10% and can be as low as 5% as well. In this view, the results are acceptable in many cases, so we can see that the frequency-based approach gives us very accurate results in comparison to the other method. In conclusion, we can say that the frequency domain is now a practical option for multi-input durability calculations and offers the possibility of significant reductions when it comes to analysis time and data storage requirements.
So what are the inputs in Patran or Nastran? There are 4 main steps. The main step is the output request. This is a required step, and just like any other Patran or Nastran run, you would need to request for fatigue life output. So in a regular run, you would request for stresses. In a fatigue run, you would need to request for fatigue output. The other option that's important to have are the material properties. Just like any other analysis where you define your E or nu, in this case also you need to define the fatigue material properties for the SN or the EN curve. And another option that is not required but is optional to the user is benefiting from additional fatigue parameters. This is optional. If defined, users can define a specific parameters related to vibration fatigue or related to how they want to output the results on the nodes or elements or etc. If not defined, all the defaults will be used. The last option, which may be a little bit more important than is which is also required, is defining the load sequence and the way the load is applied and all the stuff related to it. So these are the 4 main options. We're going to be going over some of these. So as you can see, these are some of the Patran forms. The main one, the first one that one needs to do is the fatigue output request. This can be accessed from the subcases form on the analysis. You would need to click on the output request button and then select fatigue life as your output request. In this form, users also have the option to change the form type to advanced and to be able to get more information. Here you can define how you want the elements to be included in the fatigue analysis, whether through a property or whether through an element set. You can also define what elements you want to have fatigue analysis calculated on, whether it can be the whole model or it can be a portion of model. So this is a neat tool that you can see in Patran. And again, as you can see here in the form, we have the solution type set to solution sequence 111. So because we are doing durability analysis in the frequency domain, so let me bring in my pointer. Here, as you can see, we have set the solution type to solution 111 because fatigue analysis in frequency domain is based on the assumption that we have a model that is ready to run in a frequency response in Nastran. Next step is to define fatigue material properties. So any fatigue analysis requires that fatigue material properties to be supplied. This is done using the materials application. First, you set the constitutive model to define your linear elastic material. At the moment, only isotropic metals are supported. And then once that's done, you set constitutive model to SN or EN. For frequency domain fatigue analysis, these are the 2 options that are currently supported. As you can see here, constitutive model is set to stress live, and there are 2 options for the user, whether to have the data input in tabular format or whether to use the MMPDS method to calculate the material, the SN material data. The next option is the strain life or EN. In this case, we only have the standard parameters option where you can define the SN curve, and material code is not used. Next option is to define fatigue parameters. These are some of the parameters that can be set based on the user's preference. The solution type, for example, in this case, must be set to frequency response. So once you've defined it, you see the forms change depending on the solution type you have. So in the analysis application form, that's where we set the solution. Then we need to turn on the fatigue analysis. Several options are available here on the fatigue parameters form. First, we have the general parameters. Then we have the stress line or EN related parameters, and lastly we have the analysis setting. So in the general parameters, you can define your stress units for whether they're megapascal or any other type, how you want the results to be output, whether they're averaged based on nodes or elements or other options. The next form is the one for defining the stress life or strain graph analysis. This is also defines the type of fatigue analysis to be performed. If you are doing any mean stress correction, like for example, we have the Walker method, you can define it here. And the last one are some of the options for rain flow cycle counting or the maximum RMS levels or some of the options related to vibration fatigue. Next, we will have some of the capabilities for loading in Nastran embedded fatigue. So a fatigue load entry is used to define the type of loading. There are several types of loadings that can be defined in Nastran Patran for vibratory fatigue. It can be a single random PSD or it can be a multiple random with a cross correlation. In this case, there are more than one load input and the loads are applied simultaneously. When the loads are applied in multiple input, phase relationships become very important. This means that the input needs to be described as both direct PSD and for correlated PSD and cross PSD. Correlated meaning is that the effect of one input may have effects to the other input as well, so possibly adding or canceling the effects of other loads. For example, you can see here we have a truck cab model which has 4 inputs, and each application input has 3 components and making it a 12 input total. So this will result in a matrix of load correlation, and this is much easier done in the frequency domain in comparison to the time domain. So multiple load inputs can also have multiple events, and that can be done as a duty cycle as well. And so it also allows you, Nastran vibratory fatigue in Nastran and Patran also allows you to define deterministic loading. It can be several types of loading, including a narrow band or a sine sweep or any other option that the user wants to have. For example, here we can see an example of a sine sweep on top of a random loading. The deterministic load has a frequency of 15 Hertz and it's superimposed on the PSD loading. Or here we see a representation of a single narrow band process that's applied without the underlying PSD. So several types of loadings are available. Users also can benefit from time to PSD utility that's added in Nastran and Patran for vibratory fatigue. This makes it much simpler for if you have your data in time domain. So you don't need to do a manual conversion, and you can simply input it in Patran, and the utility will convert it to the frequency domain using a fast Fourier transform. So the advantage of it is that the time domain signals can be used directly in the frequency analysis. Now let's show these in Patran. So fatigue load sequences can be defined from the analysis form. You go to the subcases, subcase select form. Actually, that's a subcase select form, as you can see here. Once you're there, you have to go to define fatigue load sequences form once you've selected your subcase to run. And then it will take you to the fatigue loading parameters form where you can define. Here I have a chart of the Nastran entries and how these are required. Some of them are described here. You can see fatigue sequence were defined, the overall load sequence or duty cycle. The fatigue event is used to define individual events for a single or multiple PSC. And then we have the RAM PS entry, and that's defined for the random analysis done in the same model. So here you can see the main Patran form. The way that users can define the load sequences is to go here on the form and right-click on the left-hand side here, and you say right mouse click to define the load sequence. Once you have the sequence, you can go here and specify the subcases for your random analysis, the subcase I and J. If you have single input, the subcases are the same. If you have multiple input or cross correlation, the subcases may be different. Once you've defined the subcases, you select them from here. It's a really easy spreadsheet type of tool. And then the next field will be activated. In this case, you will define the field that you've already defined. You selected for your input PSC. This is a non-spatial field that has been defined previously. And then if users have multiple events and want to scroll up and down using these buttons, you'll see that the event will change. And this form gives you several options, like for example, to have PSC input. This one is for a single PSC input. So if you want to have sine soup, you can select this, and you can see one row is activated because per event, one option of sine soup is available per event. And you can see here that you can define the starting frequency, the amplitude, and you don't need to change the events. It will have it here for you. So these are some of the options available to the user. If you want to create events, you just right click on the mouse button and then say create event. So these are some of the options available. As mentioned, you can have the time to PSC tool to directly convert your time input to PSC. You can have single PSC, you can have static offset, you can have deterministic loading, or you can have sine sweep loading. So this is one of the most important forms when defining the load sequence for the fatigue analysis using frequency domain. Then next option and last option will be the post-processing in Patran. So several options are available. The HDF5 results support Nastran vibratory fatigue results as well, so you can use the HDF5 format. You can use the master DBO format, or you can use the enhanced OP2 format, which is equivalent to having param post 1 in the Nastran input file. Additional outputs that are given to the user by the fatigue utility are a HDF file, which will give you several outputs as far as the fatigue output for elements and nodes, depending on the option selected. Users can also get a CSV file that can be read into Excel easily. So yeah, the RCC will give you the PDF, and the PSC will give you the transfer function data as well as the output PSC and other items. So next section, I'm going to be talking about supporting the HDF5 results from Nastran that can be now read into Patran. HDF5 is a set of data sets that is going to be able to increase efficiency and ease of use for post-processing capabilities in Patran 2017. This is actually able to read Nastran H5 results file. HDF5 HDF5 is a database that stores and manages MSc Nastran input and output data in a hierarchical structural format. So it's based on a hierarchy. So this makes it much easier for users to add or remove or update their data sets in different applications. Patran supports HDF5. You just go to the analysis and in the access results group, instead of, let's say, if before you were doing master DBL or output to attachment, now you just click on the HDF5. So some benefits are that the H5 file sizes are much, much smaller than other output files in comparison. And so it makes it much quicker for the user. The attachment time is less, and it also helps to reduce disk space. That's another advantage of using the HDF5 file. Another benefit is that it has the output in the high precision format, and it gives more accurate results as far as the precision control goes. And also, engineers can utilize HDF5 technology to easily access the output using common programming languages such as Python, C++, or Java. And this is supported for most Nastran solutions, including Solution 101 for linear static, normal modes, buckling, dynamics, Solution 400 for nonlinear analysis and optimization. So if you're running any of these analysis types, you can send the output results to HDF5 using an MDL parameter in Nastran, and then you can do the post-processing in Patran through this form. So some of the options that are available in the HDF5 are the basic nodal and elemental results, like let's say element stresses, velocity for nodes, or displacement for nodes. Also contact results, including rigid body motion, the movement of the rigid body, the contact status, contact forces. Also nonlinear output through the NLOut command, or fatigue results, as we discussed, can be also accessed from the HDF5 result file, or hyperelastic element results, elements that are used from PL plane or PL solid. Also, HDF5 supports results for part and list-based super elements. So this is another option that is available to the users. Here you can see this is for acoustics. We have the intensity normal on the finite element results, and also the AFPM in the stain plot. So this is an option that's available through HDF5. And also here is another model that you can see. We are here doing the comparison to see how HDF5 results are faster and quicker to attach in comparison to the OP2, XDB, or master file. You can see also the HDF5 compressed sizes are very, very smaller in comparison to other type of results. These are the additional quantities and outputs that were not available in an OP2 currently, and so are available now using the HDF5. A lot of enhancements to acoustic results, so acoustic pressure, acoustic intensity, velocity, or acceleration. Also complex forces for bars in both translation and rotation, or complex forces for CFast elements, connectors. These are available through HDF5. C-valve moments, strain energy output, and complex forces for C-bends and C-bars for axial and bending strain and stresses. Also, nonlinear strain and stresses for C-hex elements, C-hex 20 elements are available with the HDF5.
In this section, I'll be talking about the enhanced user interface that was added to Patran 2017. And then shortly after, my colleague Atul will have a short demo on these features and capabilities inside Patran.
Patran 2017 has been enhanced to improve user productivity by providing a modern framework for design with a better graphics, better and improved graphics. The interactive graphic user interface benefits from the latest Qt version. Qt is a platform that allows to have the same platform across multiple application frameworks. So before, it used to be that the Patran interface was different from Linux and Windows. With the new enhanced user interface, you see the identical GUI when working with Linux or Windows. So it has the common look and feel on both applications. Several enhancements that have been added. You can see multiple viewports can now be rearranged, and we can have the tab viewport option. On the right corner, you can see the button that similarly you can easily dock and undock the tab. So this makes it much faster for users if they want to have multiple viewports, and instead of previously you had to go to the viewport, you can now easily dock and undock them. So this is another feature that's been added. Also, there has been some XY plot enhancement. For example, user can zoom in and out using by scrolling down the mouse button, the middle mouse button, and you can zoom into any location you want through the graph, and you can the graph to the left and the right using the mouse, and can arrange graphs side by side easily. Another option that has been added is the interactive spreadsheet widget, which is similar to Microsoft Excel. So there are several enhancements done. It's very simple. You can easily copy and paste, cut the cells, and just much more easier to work, which will save a lot of time for the users. So these are some of the benefits. For more information, you can always refer to Patran Release Guide. It's on our website and it's available to all customers.
So hi everyone, I'm Atul. I'm going to take you through the Patran new 2017 beta new feature. I'm opening the Patran. So I'm creating one new file. I'm importing one deck. This is the model. So now I am creating multiple viewports. So there are 5 total viewports created. So at the right bottom corner there is a tile viewport option. If I click this, all these viewports get automatically adjusted in the graphics screen. I can have different views for the different viewports, like this. And if you are in one of the viewport, you can use mouse wheel middle mouse button to go scroll through the different viewports. The current viewport is highlighted by the orange color, as you can see. Wherever your cursor is, the model gets zoomed at that position. Let's say this hole, center hole. So the model gets zoomed at that position. If you want to resize any viewport, you can just double click it. It will get maximized to the possible limits. You can just drag and drop also, like this. Okay. So next functionality is the XY plot. So I have one example solved, and this is the XY plot of random analysis. This is the autocorrelation of the response and time. So after plotting the XY plot, I can select the curve in the graphics. I can edit or modify the legends, these names of the X and Y axis. I can zoom in and out at a particular point in a graph to see any peak values. I can use the left button of my mouse to drag the graph to the right and left side. Now I'll show you the spreadsheet widget. That is the laminated composite. I am importing one model which has a laminated composite material. So this is the laminated composite window. I can double click any of the cell to enter a value. Just enter value and just click the enter button from the keyboard. You can directly select the cell and enter the value. You can cut and paste on any of the cells. Cut, copy, paste, select, all options are there. You can use the tab key to navigate through the different cells. Fourth functionality is the ribbon bar. So on the empty side, if you right click on the ribbon bar, there are 4 commands: command window, RHS window, model browser, and the classic menu bar. The command window is the bottom one beside the graphics screen. It has command output, console output, and the selection choices. This can be enabled on and off. The RHS window is this one, right side form. It can be on and off. So similarly, this can be dockable. Model browser is at the left side. There is a classic menu bar which appears below the toolbar. So user can access this. Similarly, this toolbar is also at the menu bar. At my right side, there is one question mark button. So it shows the product version and the copyright information. This is to minimize the ribbon bar and maximize like this. In the options styles, there are various styles, themes like the Office 2000 black, Office 2000 blue. Some of the styles I am executing here. Like this is the Office 2016 colorful. So these are some of the UI styles. The shortcuts can be activated by pressing the Alt key. I press the Alt key and shortcuts have been appeared. For example, with the property there is P. For load BC is L is there. I press the L. For let's say the acceleration, I press the A. So in the RHS window, create acceleration window appeared. This applies to the all tabs and all the options. For example, the analysis and let's say the HDF5. I pressed HD. New and open windows are resizable. I can drag from any of the corner so that I can view various details like name, size, date modified. I can view the path here. If I have a material with the various long details in a UI form, I can use my middle mouse button to scroll down and up. This is the middle mouse scroll wheel. This is for the vertical and horizontal scroll bars. Similarly, it can be used for the horizontal scroll bar, left and right. Slider values also can be controlled. Let's say this marker size. I can have the max and min size with the help of middle mouse button.
Thank you, Atul, for your demo. At this point, I would like to finish this webinar. Thank you everybody for attending the Patran 2017 webinar. Hope to see you all in future presentations.